Welcome back to Further Solutions Academy. Don't forget, share to your friend, subscribe if you have not subscribed before, and comment on the video so that we can moderate whatever we are doing. And if you want to reach us, want to book for our online class, you can comment below, or you make use of this line to reach us. Now, with this line, you can call us, you can WhatsApp us, and also Telegram is allowed. Either of the three, you are good to go. On this video, I'll be walking you on examples on metric space. I've been on metric space and some typical examples on metric space. Now, when we talk about metric space, I've been on metric space by telling you that you must have a distance that you must not get something less than 0, which is you must get is either equals to or greater than what is 0. And I've told you the case why it will be equals to 0. It means that of that point they are the same location. The movement has not been done anyway. Now, and also it must also obey the symmetric and also obey the triangular inequality. Please take note of those things. Make sure you watch on our video. Now, don't forget what is called absolute. I think I'm going to be using absolute a lot here. Now, absolute. Okay, absolute value is the triangle inequality. Now, when we talk about absolute value, listen to this is what is called absolute value. In terms of absolute value, it means x plus y. Absolute value, it will be less than equals to of x plus of y. Take note of this. Very, very important. Now, if the story now change that I have a minus what? C. Take note of this. A minus C, it means there is one interval. B is not coming up. I think the distance is just talking about A and C. Normally, there must be a B in between. B must be here. That is what I'm saying. It means distance from here to here. Now, in a complete form, it means it will be less than equals to distance from here to here and to here to here. It means I'll be having A minus B, absolute value, plus B minus C. That is, now, can you see this will be less than what? This will be less than this, which in terms of, I can say that what A minus B, absolute value, plus B minus C is a distance, which is a distance we must not get 0. Final minus what? Initial. And I think we have done that on our coordinate geometry. All what we are doing here is the application of coordinate geometry. It will be greater than equals to what? Minus Z. That is what I mean by that. Now, let me take a 3 point. I have points. This is a point. This is a point. This is a point. Now, this is a given point. It means A, B, C. That is what I'm trying to do. It means it will generate what? Equality. Now, don't forget what I told you earlier, that x minus y, it will be greater than equals to 0. And the second one, x minus y, it will be equals to 0 if and only if s is equals to y. And I've also said that symmetry inequality, it means x minus y, absolute value, it will be equals to what? Y minus z. Minus x. Take note of that. It means when the movement is like this, you move like this. This is x, this is y. When you move like this, the same thing you are moving back. That's what I'm trying to work on. And the last one is that I have triangular inequality, which is what I put here. X minus y, minus z, will be less than equals to x minus y plus y minus z. Please take note of that. It's a distance which you know how it is. Now, with this, I can now continue by having Okay, with this, I cannot continue. But before I continue, try to understand your definition of metric space, because it's very, very important. All what I'm going to be doing on this video, it will be rest upon metric space. Take note of that. It will be rest upon metric space. Now, I think I've told you about metric space. It means we declare a distance which is I can say that s comma y, comma, okay, yes, which I have this. It means it will be a metric space for three conditions to hold, four conditions to hold. The first one, which I've done that, make sure you work on the previous video. I think I don't have time to be explaining that. Try to be on it next video. Now, when we talk about example on this, the first thing you need to understand is the standard, which is called Stupidian Distance, which I'll be having R of D, which that is to say d of x, y into b equals to y minus d. I told you that one is complex, one is real. It means on a Cartesian plane. It will be on a Cartesian plane. What is the Cartesian plane? This is a Cartesian plane. Y and x. Normally, this is called I, which is complex. This is called what? Real, which is real. Or we call it imaginary axis, or imaginary axis and real axis. Those two things combine together to generate a Cartesian plane. Now, example two, if I have d of r squared of d2, now let me try to explain this very well. Now, this is the normal common way of finding distance on our coordinate geometry. I think coordinate geometry lets us to know that distance between 2 points is the square root of the point pointed. We know point B, point A, x coordinate minus whatever. I think I'll be able to explain that. Let me explain with the head of this thing. Now, if I have this, I have a distance like this. This is the distance. I have this one as s comma x and y comma y, which is going to be the coordinates, because the coordinates will come together and generate a point. Now, once I have something like this, this is called d2. This is called d2, which is the distance I'm having. The half square is also, I'm talking about a real number. It means my d2 of 1, of 2, and also 1 of 2, it will be equals to the square root of y1 minus squared plus that is what I'm trying to explain that. Now, if I should generalize something like this, okay, for instance, if I have a d2 of 1, 2, it means I'll be having this. This is the point that generates, this is a point, this is a coordinate, this is a coordinate. This generates a given point, which we have done that earlier. It means this will be equals to root of 3 minus 1 all squared plus 4 minus 2 all squared, which I will be having 2. 2 squared become 8. I have, which is going to be what? Root of 2 squared will become 4 plus this one will be 2, which is going to be 4, which I have root of what? 8, which is the same as what? 2 root 2 units. It's a distance because it must have units, because distance, it might be in centimeter or kilometer or whatever you are working towards. That is going to be a distance. That is what I'm trying to work on. That is what I'm. Now, if I should generalize a distance of a given point now, if I should generalize it in a general form, it means a distance of x1 to and distance of y1 to yk. This is that it will be equals to square root of x1 minus y1 plus sk minus yk. That is in general form. Now listen to me. When we have 2 minus 4, normally you have it in form of what? Is in form of root, and the square is there. This will back to what you are looking for, which is because any square of a given number give us what? A positive number. Any square of a negative number, which is I'll be having minus 2 squared, which it will be equals to 4. Take note of that. The position does not matter as far is on square root. Now, the next one, which I've explained in the last video, is called tactical metric space, which I've explained that, I've explained tactical topology, which is called it when you have something like d of d1, which is going to be what? Is a tactical, which is going to be tactical matrix space, which I can say that I have points like this, I have straight points. If I'm going towards a straight goes like this. Now I want to get from one point to another. They are not parallel to each other. It means I can go like this and go like this. Now I can also go like straight A, come like this, come like this, come like this, come like. Now it means I can come in a zigzag form. Anyhow, this is called d of I. This is called d of 1. Now this is going to be point x and 2, and this is going to be y1 and y2. That's what I mean by that. It means the distance of this will be equals to absolute value of I minus x1 plus y 2 minus y1, and so on and so forth, That is what I mean by that. Now, the next thing I want to explain here is that what is called infinity distance. Now, this can be infinity distance. This is going to be infinity distance. Now, this is also known as a maximum distance, which also known as infinity distance. It means I have the distance of infinity, which is going to be s1, which is going to be y1. It will be maximum of maxi of what? Y minus y, which is going to be what? 1 s2 minus. Now, the maximum distance, that what I will pick. For instance, if I have points like this, this can be a movement is a direction. The maximum is this part, because from here, this is going to be x, it's going to be y. Now, from here to here is longer, which is going to be what? This is going to be tactical. This is going to be maximum or infinity distance. Now, the next thing I want to that you need to understand. Let me rub this part. Okay, I think it's getting better. Okay, the next one you need to understand, which is another example, we'll be talking about boundary or sequence boundary. Bounded. Sorry, let me use the word boundary, not boundary. Bounded or sequence of S of n. Now, if I have something like this, for instance, I have two functions. The functions let me to know this one function of this, and I have f of n. These are two functions. Now, it means it will be maximum of x of n minus f of n. That is going to be for all n belongs to what? Real number. Please take note of that. For all n belongs to the real number. Now, that is what I mean by maximum. It means what I've explained here. When I have a point like this can be a function. This can be a function. And this can be a function. Now, I call this function as f of n, and this one is s of n. That is, there are two functions anyway. Now, what I will just do, the maximum point where you have the highest. Now, the point of having the highest distance, it will be around here. It will be around here. This can be a distance. This can be a distance. This can be a distance. This can be. But when you have the highest, highest distance, that is called what? That is called that is what I mean there. That is what I mean by s. The maximum. It means the maximum distance of this of the function. That is going to be what I mean. Now, the next thing I want you to understand is another example when we talk about continuous function. Yes, I need to explain condition because it's a very common part of metric space. Continuous function. Now, continuous function. Okay, I think if it is continuous, okay, another example, we call it continuous. S is continuous function on A, B. Now, it's continuous on A, B. Now, if function like this is going to be a function A, B. I call this place A, I call this B. It's an interval. Now, when I have function now, I have another function this way. Now, this is the function. This is going to be f, and this is going to be f of x. Anyhow, you call it g of x. We have done mapping very well. Now, at this point, where you have the maximum, this is going to be the maximum. I'm trying to get a maximum point. Let me draw this very well. Now, when you have the maximum points, now that place becomes a big F. That is what I mean by what? The maximum. It means d of f, g will be equals to maximum of f of x minus g of x, absolute value. It means absolute value, I don't need minus. Please, when you have negation, you neglect the negative. I think it's a distance which negative is not allowed. We must not get something negative. Now, s belongs to what? AB. S belongs to AB. Now, that is what I mean by what? The continuous function on what? A, B, closed interval. Now, that is what I mean by that. The next one is that I think it's getting better. Oh, that's good. Before I end this part, let me quickly explain when we have the distance of f and g. The distance of f and g, it will be integral of a to b, which is it means these are the closed interval of fg minus g of x, absolute value of what? The g, I mean the x. Now, what am I trying to do? I have another interval of a, b. This can be an interval a, b, a, b. Take note of this. Now, since it's a, b, the first thing I need to understand is that it's a function in form of integral. It means it must be bounded. It must generate a what? Boundary, which I have something like this. It's time to draw this very well. Now, and I have another one like this. Now, this is going to be functions. They are function. This is going to be A, B, and this can be F and G. Of that. Now, this is going to be a bounded. This is what I'm going to be working on. Can you see? Now, that is what I mean by that. It means I can say that, oh, yes, to become a real distance, I can say that distance of this can be, okay. Now, if I should moderate this in a normal form of Cartesian plane, I can say that another example, which I can say that I'm allowed to say that by saying d of f of g can be equals to root of integral open from this, close interval of f of g minus in this form of squared of g. Now, this becomes a normal way of finding distance because I have the root and I have the square. That is going to be now the last part of it is that we call it infimum form. For instance, if I have, please, this can be infimum. I have two sets. Distance on a two set is a set A and B. It's a set A and B. It means this is a set. When I have something like this is a set A and set B. Don't forget the capital letter, which is denoted by what? If this A belongs to and B belongs to, now this point is the distance between the what? The two sets, which I can say that what? Distance of A comma B will be equals to infimum of, this is not maximum, infimum of absolute value of this minus this, which is A is in and B is in big B. It's in big B. Now, okay, that is what I mean by that. In illustration, if I have permit me to write this something like this. If I have my R of this, which is going to be, okay, my distance become X comma Y, which is like 0 to what? 1. It means if S is equals to Y, if S equals to Y, and if Y, S is not equals to Y. Take note of that information. Now, that is what I mean by that. It means I'll be talking about a distance of AB. Distance of AB, which is distance between this place is 1. Distance between that place is 1. Now, for example, look at this example before I round it up, before I round up what I'm doing at this point, at this moment. I think you can see metric space is a very nice part of mathematics. Now, I have something like this. Okay, examples. Look at this example. I have 1, 2, 3, and the distance. This is going to be a distance. Now, these are the points, which is going to be point 1, point 2, point 3. It will have equal distance because of what? It has D. Equilateral triangle, which 1, 1, 1. And this is going to be what? 1, 2, 3. That is what I mean by that. It means equilateral triangle. Equilateral triangle. Okay, I will be stopping here because of time. Don't forget you are home with Further Solutions Academy. Once again, thanks for watching.